Hey guys, Mrs. Colmia here. We are going to be talking about geometric sequences today. And the first thing I want you to do is get one of these. Yours are green from the substitute, and you're going to be following along with me as we fill this out. And then we're going to be talking a little bit more about geometric sequences. So let's fill in exponential first. So exponential increase or decrease with a constant ratio. And we've already talked about linear. Remember, linear functions are going to always be your arithmetic sequences. So this one increases or decreases by a common difference, which is also known as a constant rate of change. Okay, so let's move down to, let's do linear graphs first because I know you guys know what these look like. So if we've got a positive linear graph, it's going to look something like this. If we have a negative linear graph, it's going to look something like this, but they're all straight lines. If we talk about exponential graph, so hopefully some of you noticed this when we did our exponential exploration with the bunnies. Exponential equations, they start really slow and kind of slowly go up, and then all of a sudden they go up like super, super fast. And if we're talking about decay or backwards, like for example, I think there was a problem about a ball dropping, and as it slows down exponentially, and they kind of go down really fast, but then they kind of level out. So that's what exponential graphs look like. So let's talk about our equations, exponential equations. They are like AB to the x power, but we're talking about sequences, so that's really not the one we want. The one we want is right here, and this is a to the n, or y in this case, is equal to a1 times 1 plus r, being the ratio, to the x power, or to the nth power. Okay, and then linear equations, you know them as y equals mx plus b. You might have talked about that last year. The equation that we created when we were talking about, well, these aren't sequences, I guess. These are just equations. Ax plus or minus b. Could be plus or minus b up here as well. So exponential tables, these are where you can really see that geometric sequence happen. It would be something like this, 1 and 3, 2 and 9, and 3 and 27. We know this is exponential because every time we're multiplying by 3. So that's your common ratio. Linear tables, we know, look like this. So we have 0, 0, maybe 1 and 3, 2 and 6, 3 and 9, and they're going to increase by adding 3. And this was called the common difference. Okay, the last part down here is exponential situations. We've already talked about the rabbit growth. Just in general, population growth happens this way. Balls stop bouncing. That's when you are going down. And we're going to talk about the equation for exponential situations. I want you to put and sequences here so that we can write the equation there. And then let's talk about linear situations. We talked about some of these, like that was the 60 miles per gallon. And it was how far we went on a gallon, or I think we were talking about time maybe. And again, I want you to put in sequences here. I also want you to add the equation here for linear sequences. So we have a to the nth power equals a1 plus n minus 1 times d, or the common difference. And then our final exponential situation, geometric sequences. This equation is going to look like a to the n equals a to the 1 r being the common ratio, to the n minus 1 power. So that's your geometric sequence equation. We're going to talk about that and how we came up with that in just a little bit. So this is what this looks like. You're going to have to cut this in half because it is not going to fit into your iNotebook the way it is right now. So you're going to want to cut it right here, and then go ahead and cut on the dotted lines only. Do not cut on this line. And you're going to fold these in, which I know is weird, but you're going to fold them in. So you're going to fold them in like this. And so you'll have each one of these cut. And then on this side, you're going to write geometric sequences. And over here, you're going to write arithmetic sequences. I would do this before you cut it, honestly, because if you haven't already, if you cut it, then it's going to be a little harder to write that in. So you're going to have yours cut in half to fit into your iNotebook as well. So you'll probably have 2 of these, and get it taped into your iNotebook, and then move on to the next video for the lesson.